You're listening to KSG Podcast. This is a short, crisp, concise, exam-oriented, edited editorial for civil services aspirants. In this podcast, we are going to talk about clean energy breakthrough. Source for the content is The Economic Times. The Department of Energy is planning an announcement on the 13th of December 2022 about a major scientific breakthrough at the Lawrence Livermore National Laboratory, one of several sites worldwide where researchers have been trying to develop the possibility of harnessing energy from nuclear fusion. It's a technology that has the potential to one day accelerate the planet's shift away from fossil fuels, which are the major contributors to climate change. The technology has long struggled with daunting challenges. Here's a look at exactly what nuclear fusion is and some of the difficulties in turning it into the cleaned, carbon-free energy source that scientists believe it can be. Now, what is nuclear fusion? Look up and it's happening right above you. Nuclear fusion reactions power the sun and other stars. The reaction happens when two light nuclei merge to form a single heavier nucleus. Because the total mass of that single nucleus is less than the mass of the two original nuclei, the leftover mass is energy that is released in the process, according to the Department of Energy. In the case of the sun, its intense heat, millions of degrees Celsius, and the pressure exerted by its gravity allow atoms that would otherwise repel each other to fuse. Scientists have long understood how nuclear fusion has worked and have been trying to duplicate the process on Earth as far back as the 1930s. Current efforts focus on fusing a pair of hydrogen isotopes, deuterium and tritium, according to the Department of Energy, which says that particular combination releases much more energy than most fusion reactions and requires less heat to do so. Now, how valuable would this be? Daniel Kamen, a professor of energy and society at the University of California at Berkeley, said nuclear fusion offers the possibility of basically unlimited fuel if the technology can be made commercially viable. The elements needed are available in seawater. It's also a process that does not produce the radioactive waste of nuclear fission, Kamen said. So how are scientists trying to do this? One way scientists have tried to recreate nuclear fusion involves what's called a tokamak, a donut-shaped vacuum chamber that uses powerful magnets to turn fuel into a superheated plasma where fusion may occur. The Livermore lab uses a different technique, with researchers firing a 192 beam laser at a small capsule filled with deuterium tritium fuel. The lab reported that an August 2021 test produced 1.35 megajoules of fusion energy, about 70% of the energy fired at the target. The lab said several subsequent experiments showed declining results, but researchers believed that they had identified ways to improve the quality of the fuel capsule and the laser's symmetry. The most critical feature of moving fusion from theory to commercial reality is getting more energy out than in. That's it for this podcast. Thank you so much for listening. To join KSG in the courses and to crack the IELTS exam, visit ksjindia.com. You can also get a PDF of this podcast on ksjindia.com. Thanks for listening and do subscribe to our channel.